Refactoring is the process of changing existing code without changing its external behavior or functionality. Refactoring is intended to improve the design, structure, and maintainability of the code while preserving its functionality. It is not a one-time process but an ongoing activity that the team needs to embrace. In this video, let's look at an example of how you can refactor an application into a much more maintainable structure. I will mainly be using two patterns to which I will be refactoring. I will be using an AWS Serverless Application template to do this, but the refactorings applied are applicable to any application. It's very much same if you are building an ASP .NET Core application or a .NET Console application or any application using the .NET ecosystem. Hello everyone, my name is Rahul and welcome back to my YouTube channel. Here, I usually talk about .NET, Cloud and DevOps. Please hit the subscribe button and help me grow this channel. Without much delay, let's head off to Visual Studio and create a new application from a template. We will be then refactoring this application template into a different structure that's more maintainable and easier to understand. So let's click New Project and search for AWS Serverless. Let's choose the AWS Serverless Application with test under .NET Core as the option and click Next. Let's name this application as myapplication.host. I will come on to why I have named host in a short while. Let's keep the solution name as myapplication. So let's click Create. This is going to give us an option to select the type of application that we want to create. In this particular case, I will be using a blog API using DynamoDB. This simulates a real-life situation where we have an API which talks to a real database. In this case, this is DynamoDB. In your application, this could be different. You could be talking to SQL or any other NoSQL database. And this could also be an ASP.NET Web API application where there would be a controller, and instead of that, here we have functions.class. So let's use this and move on to create the application. The application is successfully created. So we have the myapplication.host project and also the myapplication.solution file. Now, to give a quick overview, since this is an AWS serverless project, the entry point is dynamically done by the AWS host. So all we need is the functions.cs or this template which links it to the particular functions that we want to host in AWS. Let's not go into much details about this because the intent of this video is not that. Now, if you want to learn more about AWS Lambda and how it works, you can check out the video that's linked here or in the description below. So let's go to the functions.cs class, which is the main class in this particular application. This is very similar to a controller class if you are building an ASP.NET Core Web API application. So let's scroll down. And here we can see this uses an DynamoDB context, which is the context that's required to talk to DynamoDB. So we have the main constructor where we set up a lot of the things for this particular class. So here we also set up the DynamoDB context. So let's collapse all these functions and we can see there are different functions in this class to get blogs, to get a blog, add a blog and remove a blog. A usual CRUD create, read, update and delete kind of style API. But if you see in this particular function, there is a lot of things going on. If we expand one of the functions, let's say get blog async, we interact with the Lambda context, get out parameters from that. So we are interacting with the AWS infrastructure and then we make some code for our domain and also interact with the database. So there is a lot of things going on in this single class. Since this is a small application currently, it's easier to maintain. However, as the application grows, such kind of function classes becomes hard to maintain. So let's see how we can refactor this into a more maintainable and easier to discover application. If you've seen my layering video earlier, I had introduced you to the onion architecture. Now this is one of the styles that I have commonly used across my applications in the past, and it has always worked well. It makes the application easier to maintain, discover, and also add functionalities to it. So if you're building a small to a medium-sized application, I highly recommend checking this out. In that video, I had created two other projects, mainly for the domain and also to handle the infrastructure. So let's see how we can create the same in this application. So let's open the Solution Explorer and add two more projects. So let's right click and say add new project and call it myapplication.domain. We'll keep them as class libraries because that's not going to be hosted by itself. So let's click class library and next. In this case, we will name it myapplication.domain and click create. Let's also create one more project using the same process. So let's click add project and select class library and name this myapplication.infrastructure. We don't need this extra class CS, so let's delete that, which is automatically getting created, and also delete the one that is created by this infrastructure class. Let's also add in the project dependencies. Let's add the appropriate project dependencies for these multiple projects. The host application needs access to both the assemblies because that is hosting the whole application. So let's add domain and infrastructure to that. The host is also where we compose the whole application. So that contains the composition root. Now the composition root is the entry point of your application. Now this could be an AWS Serverless Application, like in this case, or it can be an ASP .NET Core Web API or a mobile phone application host or anything that is hosting your application. Usually, the dependency injection and the registration of all the services happens in this composition root. This is the reason why it needs access to all the DLLs that's part of this application, because it needs to compose the entire application in that root. So let's make sure to add the references to the other two assemblies. So let's right click on dependencies and say add project reference. We can select the domain and the infrastructure projects in this case and click OK. Now the domain project does not depend on anything. So every other project actually depends on the domain project. This is why it forms an onion architecture. It peels out from the outer layers and starts depending to the core, which is the domain. So let's now add a dependency to the infrastructure and add the project reference and select domain in this case. So anything that the domain needs will be added as interfaces in the domain class, which will be implemented by these outer layer projects, which in this case is the infrastructure. So if we need to access a repository, let's say for example, we will have an interface within the domain project that will be implemented by the infrastructure. We will soon see how that's working. Now that we have the projects added, let's build this to make sure it's all working fine. The build is working fine. So let's open the Git changes dialog and create a Git repository and make a commit. Now by creating the repository from within Visual Studio, it has automatically committed all the changes that was existingly there. To verify that, let's go to the bottom right where we have the branch, that's the master, and then select view history. Now we already have these two commits automatically happening because Visual Studio chose to. Now let's start refactoring this application. Along the way, we will make proper commits so that you can review this in case you want to. Let's first go to the blog.cs class. This currently acts as a data transfer object, which is just transferring data to the external API. But as you build your application, this might have more features and might more act like an entity. Now I had touched upon what the differences on entities and value objects are in my video on layering. So let's move this blog.cs into the domain project because that is a domain concept. So let's click and drag into the domain class. We can move this into an entities folder. To do that, right click, add a new folder and name this entities. And we can also move this further inside that. Now to make sure that the namespacing is correct, let's open up the blog.cs and make sure the namespace is correct as well. So let's say change the namespace to domain.entities and let's save this class. Now we also have the old file existing here, which we will delete in a moment later. Coming back to our functions.cs class, let's start seeing how we can refactor this particular class. Now as we saw, there's a lot of things that is happening here, which is interacting with various kind of infrastructure. The AWS Serverless host, the DynamoDB, and also it has a bit of domain logic. Now the easiest thing that could come to your mind is to make a service class or a manager class or a class which is similar to that, which can manage a blog object in this particular case. Now I have seen this kind of a pattern across in different applications. Now these classes usually start out small with a get, create, update and read functions, but as the application grows, it becomes larger and larger. Now these classes could also end up becoming a dumping ground. Let's say for example, you have a user and a list of blogs, and if you want to get all the blogs for a user, would you put this under the blog service class or would you put this under the user service class? Now this often is confusing, and then you would end up dumping it in one of them, or even creating a user blog service class. Now these classes often tend to become like godlike classes, which has a lot of functionality inside that. Now it need not be named as service or manager, it could be anything. The easiest way to identify it is open up any class in your existing source code and see if it has more than 4 to 5 constructor parameters. If this is the case, it's very likely that this is more like becoming a godlike class, which has a lot of functionality and hard to refactor and change. So let's not use the manager or service kind of classes in this particular application. Let's see two patterns that helps us solve this problem. This is the Mediator pattern and the CQS principle, which is command and query separation. Let's see this in detail. Mediator is a behavioral design pattern and it reduces the dependencies between the objects. So there is a mediator in between through which you interact with other objects. With this pattern, it restricts direct communications between objects and forces them to go via the mediator object. With command and query separation, the fundamental idea is that you would divide an object's methods into commands and queries. A query is anything that reads the data and does not change existing data. So it does not have any side effects. Whereas a command is something that updates or deletes or modifies an existing data. So it does cause a side effect. If you look at the create, read, update, delete set of accesses, usually the create, update and delete falls under command and the read is usually a query. So with the CQS principle, we separate the commands and queries as separate actions or tasks within our code. Let's see how we can use these two patterns in our application. To implement the Mediator pattern in .NET, we have a library that's quite popular, which is called Mediator. Now if you scroll down, you can see this is a simple Mediator implementation in .NET. This is an in-memory implementation, so it's quite easy and fast to set up and get started with. So let's use this in our application. Switching back to Visual Studio, let's open up the Solution Explorer and right-click on the solution and say Manage NuGet Packages for the solution. Let's choose Browse and search for Mediator. Now by managing the packages for the solution, we are able to add packages to multiple projects at the same time. So let's choose Mediator, which is the library that we just saw, and install this in the domain and also the host project. And let's click Install. With the package successfully installed, let's navigate to the functions.cs class and start using it. Now to start with, let's create an instance of this within the class variable. So let's use iMediator, which is an interface that's provided by the Mediator NuGet package, and name a Mediator property. Let's keep this a private, or you can even keep this read-only depending on the pattern that you use in your application. So let's leave it as private for now. We will see how to instantiate this in a moment later, but let's start using the Mediator pattern within our functions. So let's modify the get blogs async method, which is the simplest in this case, which gets all the blogs from the DynamoDB database. Now currently what it does is it calls a DB context. It uses the scan function, which is basically like getting all the blogs within that DB context, and then it returns back to the user. Let's modify this to use the Mediator pattern. To start with, let's comment this code which interacts with the DB context and replace it to use the one with Mediator. Now if you use the Mediator class, you can see it has lots of methods on this. The one that is of interest for now is the send method. This helps us to send command and queries to this particular Mediator. Now any of the functionalities that's associated with the queries or commands gets invoked in that case. Now, in this particular case, what we need is a get blogs query. So let's go back to our domain and start adding the queries. Now, the queries and commands are a domain concept because it's related with the domain, which is why we are adding these commands and queries within the domain project. To keep them separate, let's add folders again. So under the domain, let's create a new folder which is called queries. Let's create a new class under that and call this get blogs query. Let's make sure this is public. To make this as a Mediator query and the one that can be used within the send method, I need to make this implement iRequest interface. So let's add in that interface and make sure to use the correct namespace. Now, this interface is a generic interface and it takes in the response type as well. Now, in our case, since the functions.cs is returning a list of blogs, let's return an IEnumerable of blog. So let's use IEnumerable and specify the blog class which is coming from the domain entities. So let's make sure to appropriate usings and click save. Now, since in this particular case, this query does not have any parameters, we can leave this blank. But if you are getting the blogs for a particular user, then you can add a property for user ID in this particular query class. We will see that in the next example. To implement this query, that is to have a handler, we need to create a handler class. So let's copy this class name and create the handler in the same class for now. If you prefer to keep them separate, you can do that as well. So let's add a public class, get blogs query, attach it with a handler because that's handling that particular query. Now, to have it associated with Mediator, we need to implement the iRequest handler interface, which now takes in the type of the request. In this case, this is the get blogs query because that is the query that this handler is handling. We also need to specify the response type, which is now going to be IEnumerable of blog because that is what it returns back. So let's implement this interface. So I'm choosing the implement interface and then it automatically implements a handle method. Let's see how we can implement the handle method now. So this takes in a get blogs query request and a cancellation token, which will be passed in from the calling code. To interact with the DynamoDB database, we need a repository interface because that is what is going to talk to the DynamoDB. Now, as we saw in the layering video, we inversed the dependencies and we made the interfaces belong to the calling client. So in this case, since it's the domain that needs to access a repository, let's define the interface closest to it, which is inside the domain class. So let's add a new interface inside here. So let's create a new item, choose interface and call this iRepository. Let's make sure to keep this public and also add in a generic type because this can be for any repository. So for now, let's add a simple method which returns a task of IEnumerable of the type T, which will be replaced to blog by the calling application, and define the function as getAll. Now it doesn't need any parameters in this case, so let's leave it blank. Let's make sure to add the appropriate usings and we have the interface defined. Now I can start using this repository within our query handler. So let's switch back to get blogs query and inside the constructor, let's inject an iRepository. Now since I am dealing with blogs, I need an iRepository of blog. Since this is generic, we can give it any class that we want. Let's call this blog repository. Let's make sure to create a backing variable for this. So let's create and assign a field blog repository. So it automatically sets this inside the class. To start using the blog repository, let's change this not implemented and return the blog repository.getAll method. So this simply proxies through to the repository in this particular case. As your application grows, you might have more logic inside your domain and you will be adding that inside this class. Now one thing to note here is that I'm using the blog entity itself as the return for this query class. Now this is because I need all the properties back to the API. Now if you only need a subset of these properties, let's say this is a page where I just want to show the ID, name and the date and I'm not worried about the content, then I can create a new class that maps to this. So in this case, what will happen is you will have a get blogs query and you can also have a get blogs query response and use that as the response type. You will be doing the appropriate mapping inside your repository class. Since in this refactoring example, I intend to keep the behavior the same, I am not doing that. Now that we have the query and the handler created, let's go back to the functions.cs class and start using this query class. So let's call the mediator.send, call in the new blog query method. So let's create a new instance of that and call that in here. Let's make sure to add the appropriate usings. Let's add the closing brackets and the semicolon. Now we can add the variable blogs and await on this call. Now this is going to return back an enumerable of blogs, which is what the query handler is doing. Once we have the blogs, we can start using this inside here. Since this is a enumerable, let's use the count function on that. Let's also return the blogs, in this particular case, insert of the pages. With that set up, let's go into the infrastructure project and start implementing the repository that we just created. So let's go to the infrastructure, create a new class. Let's call this DynamoDB repository because this is a repository that deals with Dynamo database. So let's call that appropriately. Let's make sure to make this public and then implement the interface iRepository of T. Since this has a generic type inside the interface, let's also make the repository implementation as generic. So this can implement for any type. Let's implement this interface, which asks us for the getAll method. Now, if we come back to the functions.cs, we saw that we used the DynamoDB context and used the scan async method. So let's copy up the DynamoDB context and start using that inside the repository. So we will inject that into the constructor of the DynamoDB repository. Now let's add in the appropriate packages into this infrastructure project that can talk with DynamoDB. So let's use the version that's already installed in this project in the host project. With the NuGet package installed, let's call this the DynamoDB context and add a field to this class. With this specified, we can start using this inside the getAll method. So let's return, call the await, and on the DynamoDB context, we can call the scan async, give the type of the T because that's what we are acting upon, and then call the get next set async. This is exactly the same that's happening in the functions.cs. It's first calling the scan async, it's passing in a null, and then calling the get next set async. So let's come back, make sure to pass a null to the scan async, and return back the result from this particular class. Let's also add in an async to make this to compile. I usually prefer to keep the calls to subsequent functions in LINQ on different lines. So let's format it accordingly. Now this allows us to keep to the left aligned, which is more easier to read for me. But your preferences might be different. Let's save this class. With that set up, let's now start wiring up all these different classes and interfaces that we have added inside the host application. Now, if you are building an ASP.NET Core application, this is going to be under the startup class and in your configure services method, which is where we wire up the dependencies. Now, if you're new to dependency injection in general with ASP.NET Core, I highly recommend checking out my video, which will be linked here and in the description below. Since the startup.cs class does not exist inside here, we can create a similar class inside the host project. So navigating to the host, let's create a startup.cs class inside here. You could name this any way you want, like Bootstrap or anything that you prefer. I'm just keeping it startup so that it's very similar to ASP.NET as well. Let's make this a public static in this particular case, since we don't need an instance of this class. Let's add a new method. We can name it configure services or init or anything as you prefer. So let's return a void for now and call this configure services. Let's make sure to mark this as static because the class is static. To start configuring the services, we need a service collection. So let's create a service collection instance and call in the new service collection. Now this could be any other dependency injection container, like if you want to use AutoFac, you can use that as well. But in this case, I will stick with the natively available ASP.NET Core dependency injection provider. So let's use the Microsoft Extension dependency injection package and install that into this project. With that installed, we have this instance created. Let's first register the Mediator related classes into the service collection. Now, to do that, the Mediator provides a NuGet package that can easily integrate with the service collection class that we just created. So it's called the mediator.extensions.microsoft.dependency injection. So let's copy this and go to our host project and add this as a reference. So let's go into host, dependencies, manage NuGet packages, and browse for that package that we just copied. Let's add this to this current project. Come back to our startup class. We can add the using Mediator namespace and start using functions from that. If we navigate back to the web page, we can see how to use this. If we just want to specify one handler, we can add the type of that handler. Or if you want to add all handlers and the queries inside an assembly, you can use the assembly registration format. In our case, let's use the assembly format. That makes it easier. So let's copy this line, switch back to our startup class, and call this on the services collection instance that we just created. Now this calls the add mediator functionality and then specifies the assembly that it requires. Since all our queries, commands and handlers going to be part of the domain assembly, let's use a class from the domain assembly. So let's copy the getBlocksQuery class, navigate back and use that instead of startup. Let's make sure to add the appropriate usings, and this gets the type info using the reflection and specifies the assembly here. Now this registers all the commands and handlers and the queries that we might add in the future to this particular assembly. If you have them in different assemblies, you can register that here as well. With that specified, let's now register the repository class that we created. To do that, let's call the add transient method on the service collection, specify the type of the interface. Now since this is an open generic, I need to use the type of rather than using the generic method on the transient function. So let's specify iRepository of t. So I can specify it as an open generic. Make sure to add the appropriate usings and specify the implementing type. In this case, that is going to be the DynamoDB repository, and again with the open generics. Now let's add in the appropriate usings as well and make sure we use the appropriate class name. The only thing that's remaining is the DynamoDB context. If we go back to the functions.cs class, we can see how this is set up inside the constructor. So if we scroll up and expand the functions, this is using the DynamoDB context and specifying an iDynamoDB client. So let's do the same to get this connected inside our class. Now, the template also uses a table name variable which it determines to find the table name. So if the environment variable doesn't exist, it just uses the class's name as the table name, which will be blog in this particular case. So let's copy all this inside our startup class and use that inside of there. So let's remove this from here and paste it inside the startup.cs. If you want, we can create a new function. Let's say register DynamoDB and keep that inside that particular function. So let's also pass in the service collection in this particular case. So let's create this new method inside this class itself. Now we can paste in the copied code and start registering the DynamoDB inside of that. So we need the table environment variable, which is also there inside the functions.cs. So if we scroll up, we can see this constant being used. So let's copy this comment and paste that inside the startup.cs class as well. This needs a few using statements, so make sure to add them. And instead of assigning it to the DB context, let's add this DB context to the service collection. So let's get this as a temporary variable and use that to register inside the service collection. Let's say service collection dot add singleton, because that's how the DynamoDB context needs to be registered. Specify the iDynamoDB context, which is the class that we injected into our repository. So if we go to Dynamo class, we can see there is the iDynamoDB context. So let's switch back to startup and inject in the instance for that, which is DB context. Now in this particular registration, it expects this application to run in the AWS infrastructure so that it can talk directly to the DynamoDB instance on it, which is why we don't see any connection string or user credentials getting passed. Now since I want to be able to run this on my local, I will set this up to do that. Since this is of not much focus for this video, I will simply copy paste that code and not go into the details of that. If you want to know about it and DynamoDB in general, you can check out my video linked here or in the description below. So let's copy and paste a few config that I have already created, which is a credential and specifying a basic credential which I had created from the AWS portal. It is using a client ID and a secret to access that. Once this is specified, I can use this when I create the Amazon DynamoDB client. So I can pass the credentials and also the DynamoDB config that I have created. So let's use the DB config here. So this is going to use this credentials and this region to connect to the DynamoDB instance. Now once that is set up, we have everything set up for our application. We need to start using this startup class inside of our functions class. So let's save this, go back to our functions.cs, and inside our constructor, let's set up the Mediator instance. So let's make sure to remove this additional space. In here, we can say this.mediator is equal to, we can use the startup class, configure services, and resolve a Mediator instance from there. Now since the configure services currently does not return anything, let's make this to return the service collection. So let's return the service collection, and also let's make sure to build the service provider before we return this. So we are returning a build service provider. This might differ depending on the dependency injection container that you use. Now this is going to return an iServiceProvider instance. So let's change this void and make this iServiceProvider. With that, let's go back to the functions class and resolve the instances from here. So here we can say this is the service provider dot get service, and we can use the generics and specify iMediator. To get this to work, let's make sure to add the appropriate using statements. So let's call Microsoft.extensions.dependency injection in this particular case. And this now compiles. So we are creating the builder and getting a service explicitly inside our functions class. If you are doing this in ASP .NET Core, this will be automatically done by the startup class and the configure services method. Now that we have the Mediator instance resolved, this will be working when the getBlocksAsync method is called. So we can safely remove these two commented code in this case. Now let's build this and run to see if it's working. So let's keep a breakpoint here, build the application. The build is successful. So running this application is now going to launch a Lambda test tool, which can be used to test serverless applications in localhost. Now, if this is an ASP.NET Core Web API, it would have automatically launched it inside a browser. The experience is very similar in Lambda as well. Now, this is the test tool, so it allows us to call the different functions inside that test tool. So since we want to call the getBlocks, let's make a request to the getBlocks endpoint. If we switch back to our code, you can see this is expecting an API gateway request. So let's make an API gateway request. So scrolling to API gateway proxy, we can use this to make a call. So let's call the execute function. This hits the breakpoint as expected. It's going to send the getBlocks query. So let's navigate to the getBlocks query and make sure to put a breakpoint inside the handler. So once the query is getting invoked, it's automatically coming to our handle method, which in this particular case is calling into the blog repository. So let's step into this, and this calls into the DynamoDB context and returns the scan async result. So let's return this. Now we can see here, it returns us two blogs, which was there inside the DynamoDB. So let's go to the Amazon console. So let's go to aws.amazon.com. From the console, let's navigate to the DynamoDB instance for this particular region, which is Sydney, which is the same as I used inside our application, and go into tables to see the data. Here we already have the table named blog, and we have two items under that. This is exactly what is getting returned back by that API call. Now we see that there is a test and a test content. So if we navigate back, we can see there is a test and also the test content returned back in this response. Let's navigate back to Visual Studio and make sure to commit these changes. So let's open up the Git changes. Let's give a meaningful comment. So let's say refactored to Mediator and CQS pattern, modified the get blogs method. And let's make sure to commit all the changes. Going back to functions class, we still have a couple of methods that needs to be refactored. Now let's do an example for the add blog async, which in this case will be a command. So here we are adding a new blog to the DynamoDB database. Now in the add blog async, you can see this is getting the data from the request and deserializing it into a blog object. And it is explicitly setting a new ID and the created date timestamp. It then saves this blog into the DynamoDB context and responds back with a success message. So let's refactor this to use the CQS pattern. As we saw before, this is modifying existing data, so this needs to be a command. So let's open up the Solution Explorer, add a new folder under the domain and call this commands. We can create a new class, let's say add blog command. Now as before, let's make this public and implement the interface I request. Since this is a generic type and we need to return, but a command usually does not return anything. It just modifies the data and returns back a void. Since we cannot use void, Mediator provides us a class which is called unit, which is a null value. So it represents a void instance since void is not a return value inside of C#. Now since this needs to add a new blog, let's take in a new property which is of type blog. So let's add the property, specify blog, and also specify blog as the property name. Now if we want to add a constructor so that this cannot be created without specifying it, we can use the generate constructor and make sure to specify blog. Now this checks for null and throws an exception automatically. To implement the handler, as before, let's use public class, add blog command handler, and use the iRequest handler interface. Specify that this is going to handle the add blog command and it returns a unit, which is empty. So let's implement the interface. As before, let's take in the repository as the dependency. So let's use the constructor and inject in the iRepository of blog class. Now let's name this blog repository and add a backing field inside this class. We can use this inside the method handle and call the save method. So let's say return blog repository dot save and pass in the blog object from the request. So let's call request dot blog. Now since we don't have the save method defined, let's generate this method inside that interface. Now navigating to it, it creates the save and returns a unit. But let's remove the unit since we don't need to do that. So let's navigate back. We can call await and return a unit dot value explicitly. So let's also make sure to add the async method because we have awaited here. Now this is complete. So let's go to the DynamoDB repository method, which now expects to implement an additional method, which is the save method. Now since we have the blog object coming up here, let's call the save method on the DynamoDB context. So let's say return await DynamoDB context dot save async and pass in the blog object. Now this should be of type T because it's a generic repository. So let's name this T and call this as item. So let's also rename this as item and this is expected. So let's go to the interface and also make this as type T and specify this as the item. So let's save this, go back to DynamoDB repository and add in the async. Since we don't need to return anything, let's remove this return statement. So it builds as expected. Now coming back to our functions.cs, we can modify this add blog async to start using the mediator. So let's remove this direct call to the DB context and call the await mediator dot send and specify the new add blog command. Since this is coming from the commands namespace, let's add the appropriate namespace and pass in the blog object. In this case, this is going to be blog. Now this is throwing an error because this has created an instance of the blog from within the host application. So let's go back and delete this blog class that was existingly part of the host. So let's delete this come back to functions.cs and make sure it is using the appropriate blog object. In this case, it has to come from domain.entities. Inside the startup.host, let's make sure this also uses the appropriate namespace for blog. Now, since I know that the test project is also using an instance of the blog, let's make sure to update the namespaces inside that as well. Now, with that all fixed, once I build, it should be working as expected. So let's navigate back to the add blogs command. Make sure to add in a breakpoint here and run this particular project again. Now, there is a slight issue with this Lambda tool on the Edge browser. For some reason, this combo box does not expand to choose the other options. So let's use Chrome and then start using it for our URL interactions. Now you can see all the other methods that's available as part of the function. So in this case, let's call the add blog, and then similar to we can use the API gateway request, but now we need to pass in the name and the content for the blog inside of body. So let's rename this test to be the name. So let's say this is from app and add in another property which is going to be the content. So let's make sure to delimit this with the slash. Since this is within the body, which is a string, we need to delimit it using the slash for the double quotes. So let's say app content. And again, use the backslash and close this. Since these are case sensitive, let's make sure to use the uppercase letters. Let's switch back to Visual Studio. Also put a breakpoint inside the add blog method and click execute from the UI. It hits the add blog async method and we get the request and the context as expected. So if we step through this, we can see the blog object now has the from app and app content as the properties being passed in. So let's continue the execution, which hits the add blog command and the associated handler with that. Now this calls into the repository and the save method. So this is going to add it into the DynamoDB context. So let's continue the execution. This returns back the ID as expected with this API endpoint. If you were to switch back to the AWS Lambda console, let's go to the DynamoDB and refresh this, and we can see a new record being created, which is the app content and from app that we just passed in. So we have also refactored the add blog async to this new pattern. So let's stop this, open up the Git changes and commit the changes. So let's say moved add blog to Mediator pattern. And let's commit all the changes in here. Going back to the functions.cs, now you know how to change the remove blog async, which is going to be a command, and you can move this exactly as before into a command inside our domain class. And the get blog is also going to be a query like the get blogs async. In this case, the get blog is also going to have an extra ID parameter, which is going to be passed in as the parameter like we passed in the blog for the add command. Now by moving into the Mediator pattern and using command and query separation, we have separated out the different concerns. So there is a host application that deals with the AWS serverless hosting. There is a domain which deals with our domain logic, which handles and defines the commands and queries. And there is also the infrastructure layer, which handles the infrastructure related code, which is basically in this case talking to a database. There is a lot more cleanup that you can do in this particular function template, which I'll do separately and push this up to the same repository. So I'll add appropriate Git comments so that you can go through it if you require. Now, the other thing to note in the startup.cs, for now I have hard-coded the credentials, which typically I wouldn't do in a real-life application. I would be moving this to an Azure Key Vault, or in case of AWS, I'll be moving it to a parameter store. Now you can pick and choose whichever works for you. While in local development, I choose to maintain them inside the secrets manager, which is available as part of .NET Core. If you are new to that, you can check out my video linked here or in the description below. I hope this helps you to understand about CQS, Mediator, and how to apply this refactoring with an existing application. Now open up your current code that you're working, look for classes that has more than 4 or 5 constructor parameters and see if there is a possibility to introduce this pattern. Now start slowly and introduce this one by one. Like we saw, make sure to make git commit changes very frequently once you have something working. Now this helps us to revert back the changes easily whenever there is a problem. We don't end up with having a huge pull request with lots of changes. We can slowly and steadily improve the quality and the maintainability of our code base. Now this is exactly what we expect from refactoring. In an upcoming video, I'll also show you how to have test that is supporting these refactoring. Now since the default template didn't have many tests, I didn't want to show that in this current video. But if you want to be notified when that comes out, you know what to do. Please make sure to hit the subscribe button. If you like this video, please hit the like button and also feel free to drop in comments or questions in the comment section below. If you're there on Twitter, also make sure to send me a tweet. I'll put my Twitter link in the description below. Hope this helps. Thank you and see you soon.